Okay, so far we mentioned about different normal forms like 1NF, 2NF, and 3NF, standing for first normal form, second normal form, and third normal form. And we also learned functional dependencies, different types of dependencies, like for example, full key dependency, partial dependency, and transitive dependency. And these are like identifying these dependencies in a given table is very important because that is what help you to identify the normal form of the table. And that is how you know, for example, the table is 1NF, 2NF, 3NF, or so ever. So first normal form, just do a quick review. It means that there is no repeating groups in your table. So the whole idea is that you cannot have, like for example, a cell in your table including multiple values, right? So for example, you cannot store two different like phone numbers. If person, for example, has two phone numbers, you cannot just list them, separate them by comma in one cell. So we have to think other ways to design this, either putting it in another column like phone number 1, phone number 2, or like putting it in a separate table. Depends on the design and the assumptions. And so we call this atomic values. So it should be atomic values, meaning that no repeating groups and all cells should have only one value. And so as you see here, we have we started with this table, right? And which is obviously not in first normal form. And the reason it is not in first normal form is because we have multiple values here storing in one cell. For example, you can see the instructor name, different instructor names, different course titles, different instructor locations, and these are all stored in one cell. So this table is not in 1NF because obviously the values are not atomic. Now, if you look at these two tables in the bottom, so we just try to break this table into two tables in a way that we wanted to separate these values put them into different rows, right? So for example, one row here, and so on. So okay, this is writing now like this, right? So we try to separate these into different rows. And so if you do this, so you will end up with this table, right? And we put also a student ID. We only keep a student ID here because we do not need student information in the same table, right? And we only keep a student ID as a foreign key to link these two tables. Now, this table, the bottom right table, is still not in the normal form that we want. It's still not in 3NF. But the focus on this slide is only the first normal form. So right now, all the tables like these two, both of them are in first normal form. Now, so this is just what we converted the previous table that was not in 1NF, right? Resulted in these two tables. And we mentioned that we use a student ID as the foreign key here. So the question is, what is the primary key now in this new table? Obviously, student ID alone cannot be primary key in the table in the bottom, right? And because as you can see, we have, for example, a student ID is repeated. So a student ID cannot uniquely identify each row in this table. Course ID, the same. So as you can see, we have, for example, different courses with the same ID, right? So also course cannot be the primary key. But the combination of course ID and student ID can be served as the primary key in this table. And we still have some issues here. And I'm going to explain it when I'm talking about second normal form, reviewing the second normal form. But for now, we just try to make this table into 1NF, which is the case now. And then we talked about second normal form. So we said a table is in second normal form if it is already in 1NF and it has no partial functional dependencies. And partial dependency means that you have one or several maybe columns, that depend only on part of your primary key and not full primary key. So if we have a table with single column primary key, that is your primary key is only one field, one attribute, then it is obviously there is no chance of having partial dependency, right? Because then even if there is dependency, that's a full key dependency, even if there is any dependency on the primary key, because the primary key has only single part. But what if we have composite primary key, like the case, for example, in this slide, right? So now here we have a composite primary key, student ID and course ID, and we have partial dependency. So based on the definition that I just mentioned, what is the partial dependency here? Hello? Yeah, course title and course ID are partial dependency. Why partial dependency? Because course title depends only on part of your primary key, which is course ID. So primary key here is student ID and course ID, and course title only depends on course ID and not a student ID. Why? Because a student ID cannot uniquely identify course title. If I give you, for example, this is student ID, right? Look at the third row. If I give you, for example, this is student ID, and I ask you, does it like identify the course title, uniquely identify the course title? Obviously no, right? Because so you can see like this is the student ID with this course title. Same student ID, different course title, right? And so each student can take several courses. So it's not like if I tell you what is the student ID, you can identify the course title. You cannot tell me just one unique course title. But on the other hand, if I just tell you, for example, this course ID, can you uniquely identify a course title? Yes. This is the ID for example, database management. This is the ID for the unique identifier for system analysis. And as you see, again, the same, again, the same thing here. Again, the same thing here, right? So as you can see, like these both courses here, both course IDs, right? So these are same course. So wherever you see the course ID in this table, you see the same course title. And that's why there is a partial dependency between course ID and course title, or we can say course ID can uniquely identify course title. But there is no such relationship with the student ID and course title. So since this is your primary key, and because course title depends only on part of your primary key, which is the course ID, so this is a partial dependency. And this is all you need to know for, this is all you need to know for the second normal form, right? So if a table has partial dependency, like the case here, it means that it is not in 2NF. So this table is in 1NF, but it is not in 2NF. Now, going to the definition. So this is just what we mentioned. Let's say A and B are your primary key. So this is your primary key. And if there is a dependency, let's say between D and only B, right? This is a partial dependency. Now, let's say C depends on both B and A. For example, you have a student ID, course ID, and grade, right? So if A is a student ID, B is course ID, and C is grade, then this is a full key dependency because grade depends on both a student ID and course ID. Because a student, like having a student ID alone, you cannot uniquely identify grade because each student can have different grades for different courses. And similarly for the course ID, it cannot uniquely identify grade because for each course we have several grades, right, from different students. And so whenever you have this situation, but let's say you have, for example, a student name here, right? That's a partial dependency. Or if you have a course title depends only on the course ID, which is part of your primary key, and there is a partial dependency. Now, let's say you identify this functional dependency. You identify that the table has partial dependency, and therefore it is not in 2NF. And so you want to normalize it into 2NF, right? How do you normalize it? So normalizing to two relations, so we put it into two tables, but how, right? That is the important question. How do we put it into two tables? So you find the dependency and you break that into two tables. So for instance, if the dependency is between D and B, right? So because D depends on only B, so you put B and D in a separate table. That's how you normalize it into two relation. So let's assume that A is student ID, B is course ID, C is grade, and D is, for example, course name or course title, right? Now, course title depends only on course ID, so you put course ID and course title in a separate table, for example, a course table, and then what is left is ABC, right? Because you have to keep both A and B, because B is a foreign key here, and A and B together form your primary key, so you still keep B here, but you remove D. And so what is left is ABC, which is, for example, a student ID, course ID, and grade, right? And there is no partial dependency left. Both of these tables are in second normal form. And this is what exactly you're seeing here. So we have the table on the top, which is obviously not in 2NF because we have a composite primary key, which is a student ID and course ID. And right now I'm talking about this table on the table on the here on the top. So this is your primary key, right? So this is the primary key. And then we have partial dependency, obviously, between course ID and course title. So this is partial dependency. And these like dependencies, like for example, if you say, let's say grade, right? So you see here this dependency. So grade depends on both parts, right? Depend on both a student ID and course ID. So this is a full key dependency, right? So this is a full key dependency, and that's why you see it like this, right? Because grade depends on both a student ID and course ID. None of these columns can uniquely identify grade, but both of them together. For example, this student's grade on a specific course is unique, right? So you can only take one grade on, for example, a specific course. And then we have several other columns like instructor name, instructor location. And so always your primary key can uniquely identify all the columns. So if this is, for example, your primary key, a student ID, course ID, so it can uniquely identify all the columns, and that's also the case. Now, how can we normalize this table? So the point here is identifying the partial dependency, which we found it here. And now we want to, so this is the important part, right? So the dependency between course ID and, so this is your, in your exam, if I ask you to find this, right? So you have to mention that, for example, this is partial dependency. You have to write the name of the dependency. So this is partial dependency because it only depends on part of primary key. How can we normalize it? Easy. Put this, right? Put this, like first remove this from this table and put it into a separate table with course ID, right? So now you have, for example, course ID, course title, right? And then you have the rest. So this one, like this example, separated in another way, doesn't matter. Even if you do that at the end, you have to, even if you put instructor name and instructor location, even if you keep it like in the original table, eventually you have to put it in a separate table, right? So in either way, like here or here, you have to put instructor information also in another table because of the transitive dependency that I'm going to explain next. So we put them into two different tables, and so the way that it did here is it put like the full key dependency, keep it in one table, a student ID, course ID, grade, right? Because this is now a clean enrollment table without like this one. This one is 3NF, right? Because there is no partial dependency, although you have composite primary key, but there is no partial dependency. And here is an important thing. If you have a single primary key, for example, let's say this table you have a single primary key, right? So if you have a single primary key like this one, you cannot have partial dependency. There is no way of having partial dependency. Now, if the table is already in 1NF, right, which is the case here, right? We don't have repeating groups. We do not have multiple values in one cell. So each cell has only one value, and by one value, I don't necessarily mean one word, right? For example, system analysis has two words, but I mean one thing, right? So we cannot store two different things in one cell. Now we do not have two different things, for example, two different courses in this cell, two different instructor location in this cell, right? So this is in 1NF. Now because this is 1NF, and since it doesn't have partial dependency because we have single primary key, so single primary key, no partial dependency, right? No partial dependency. Let's say PD stands for partial dependency, otherwise I'm very slow in typing here. Now because of this, so this combination gives you 2NF, right? So this table here, this table, the one in the bottom right, is in 2NF, and the reason is because there is no partial dependency and table is already in 1NF. Now this table is in 3NF, the one in the bottom left is in 3NF, because as I explained last week, and I'm going to review it now, 3NF means the table is already in 2NF, right? Plus no transitive dependency. So no transitive dependency. This means 3NF. So 2NF means 1NF plus no partial, right? So 1NF plus no partial. Now, this table already has no partial dependency, so this is in 2NF, and because it's already in 1NF as well, we don't have like multiple values in one cell, and also we do not have any transitive dependencies because the only column other than the primary key that we have here, this is your primary key, the only column is grade, and there is no partial dependency between grade and other part of our primary key, and there is no other column that this can depend on, right? Transitive dependency. Anyone recall what does transitive dependency means? Not part of the key, but there is a dependency. Yep. So dependency between non-key column, when a non-key attribute depends on another non-key. Exactly. And by non-key, we mean non-primary key. So it can still depend on, for example, the foreign key, right? In this case, there is no other column, and so the table is in 3NF. So this is for this, and this one also is in 2NF. Now the table on the bottom right, the red one, is it in 3NF? No, it is not in 3NF because we have transitive dependency, right? So we have transitive dependency between instructor name and instructor location. So instructor name can uniquely identify instructor location, because if I tell you, for example, Miller, you can tell me this is the office, right? Or if I tell you, for example, Mona, you know where is my office, right? And my office is CB 140. I do not have multiple offices, right? So given my name, you can uniquely identify my office location. And that's a transitive dependency because instructor name is not a key. Now, even if it was instructor ID, so let's say this was instructor ID, right? And here you had some numbers, right? So like instructor ID 1, 2, 3, 4. Now, it could even be like this, 1, 2, 2, right? Even if this was the case. So still, there is a transitive dependency, although instructor ID here is a foreign key, right? It's foreign key because instructor ID in another table should be the primary key, right? If that's the case. So even if there is such situation, you still have transitive dependency. But in general, transitive dependency means dependency between two non-key columns, like in instructor name and instructor location. Do you have any questions? So these are all the normal forms that we covered so far, and I'm going to explain one last example for the hospital example, and then we do the Kahoot. No questions? Okay. So this is just explaining what I already mentioned, right? Student ID and course ID, course title, these are the name of the columns, and then the primary key is student ID, course ID, and like a student ID and course ID together can uniquely identify grade. So this is the full key dependency, right? Course ID, course title is partial dependency because course ID is only part of your primary key. Now, if you want to normalize it into 2NF or second normal form, you remove partial dependencies, right? And so you then have, for example, a student ID, course ID, grade, and then course ID, course title, instructor name, instructor location. And 3NF, as I mentioned, A table is in 3NF if it is already in 2NF, that is also in 1NF, right? And then there is also no transitive dependency. So a table in 3NF should like have atomic values, no repeating groups because it should be already in 1NF, should not have any partial dependency, right? Because it should also be in 2NF, and then no transitive dependency, which means one non-key column dependent on one or more non-key columns, right? So dependency, there is no dependency between non-key columns. So we want to like basically removing all these dependencies. So let's say you have A, B, C, D. So these are the columns of your table. Now you have, for example, A as your primary key. And so if A is primary key, so one dependency is that A can uniquely identify all the columns, right? So that is obvious. And this is full key dependency because all the columns depend on the primary key, and primary key, or you can say primary key can uniquely identify each of them. Now, C and D, like these two, let's say, like the example we had, instructor ID, instructor, for example, name, or instructor name, instructor location, there is a transitive dependency here, right? And these are non-key transitive dependencies. So if you had that, so if you have a table like this, where there is, for example, let's say the table, so my question is, this table, the one on the top, is it in 2NF? So assuming it is in 1NF, is it also in 2NF? Yes, it is in 2NF because we have a single primary key, right? So the primary key has only one part, so there is no possibility of a dependency on part of primary key, right? This is only one part. So whatever dependency is on the primary key in such tables is full key dependency. And then we have transitive dependency between C and D, right? So it is not in 3NF. How to normalize such table into 3NF? Similar to 2NF, you just break this dependency. So put it in another table. So you put C and D in another table, and then what is left is ABC. And so in the context of our example, this was the transitive dependency between instructor name. There was a transitive dependency between instructor name and location. So you put it in another table, right? Instructor name and location goes into a separate table. What is left is course ID, course title. But obviously, we also put instructor name in the course ID because instructor name is the primary key here, right? So we should put it as a foreign key. And so I think this is clear why we also put instructor name here, right? We always add foreign key to the many side of the relationship. So again, I have this now. So this is your foreign key, right? Instructor name. Now, is this the best like primary key in this table? No, like in practice, you may have instructor ID, right, as the primary key. So instructor name, student name, but like names are not really good for primary key. So this is just as an example, but in reality, it could be like instructor ID, name, location, and then you would see instructor ID in this table. And so third normal form. So let's say you have like this table. So we see like these are the columns of your tables, and this this table is in 2NF because there is transitive dependency between instructor name and instructor location, right? So there is a transitive dependency here. So the table is not 3NF, but it is in 2NF because we have a single primary key, right? So there is no chance of partial dependency. Table is in 2NF, not 3NF because of like this transitive dependency. And then we break it down into separate tables, like putting instructor name and location into another table. Now this table is in 3NF, right? Because now the dependency between instructor name and location doesn't matter because instructor name here is your primary key and this dependency is full key dependency. So the type of dependency that we learned is full key dependency, right? So this is full key dependency when you have a column that depends on all part of your primary key. And we can also conclude that if we have a table with single primary key, right, with single primary key, the dependency between like all the columns to the primary key is a full key, right? Also, you may have a composite primary key, like course ID, student ID, and grade, right? So let's say this is a course ID, student ID, and grade. Now grade depends on both part of primary key, right? So this is also an example of a full key dependency. So this is full key dependency. We also have partial dependency, which we explained. It means that a column depends only on part of your primary key. This cannot happen in a table with single primary key. It is not possible. But if you have a table with, let's say, this table, right? If you have a table with composite primary key, you may have a partial dependency. For instance, if you have a student name here, right? Then there is a partial dependency between a student ID and a student name, right? Because a student name only depends on a student ID and not on course ID. So the dependency is only on part of your primary key. And this is an example of a partial dependency, right? And then we also have transitive dependency, that is dependency between non-key columns, right? Like, for example, if you had instructor ID and let's say you had also instructor ID and instructor name, right? Then this is a transitive dependency. So let me put it in another color. So this is, I really like to have like these different colors here, instructor ID and name. So this is also a transitive dependency because this is a dependency between non-key columns. Now, so I think these are, we already explained these a lot. So I really expect you to know different types of dependency and normal forms. And let's go to the next slide. So these are the normalization process, which I already explained. So you identify all your candidate keys and functional dependencies. So how do you do it? You first check if the table is in first normal form, right? So first normal form means no repeating groups. All values should be atomic. If not, remove the repeating groups, the same way that we did in our example. And then you check if the table is in second normal form or 2NF. If it is not, we have to remove partial dependencies because 2NF means table has partial dependency. And finally, check if your table is in 3NF or third normal form. If not, remove the transitive dependencies. Now, this is the other example. As I mentioned before, like this one, this is not like really an example of a relational table, right? This is just a report. So this is just like a physician report listing patients, procedures, and charges for each procedure. And so the problem, if you have this table, if you just put this report in a table as is, right? So if you just keep this structure, then there are several problems, right? So first of all, it's like a flat file, like a report, right? Not a relational table. And also we have separate, so you may have, let me first show you the table. So if you just put this report the way it is, like 1, 2, 3, 4, 5 columns here, and so we have okay, it added also some other columns, but the rest are the same. So we have date, patient code, patient name, procedure. So we have date, patient code, patient name, procedure, and charge. Now we also added, for example, doctor name and a specialty. So let's say you put everything into one table. So what is the problem here? Several problems. First of all, as you see here, so you have, we have this, right? So if this is your like different rows, so as we see, we have several values, right, in one cell. So obviously we cannot put two different things in one cell, right? So we cannot put both 35 and 75 as a charge in one cell. We cannot put both, for example, examination and X-ray in one cell. So we have to put them in separate rows, right? Into separate rows. Otherwise, you will end up with, for example, something like what you are seeing in the next page. So otherwise, you'll see something like this. Now, we also have two additional columns here, doctor name and specialty. And so there are lots of redundancy here, right? And if you want to find what is the primary key, so primary key can be a combination of doctor name, date, patient code, and I think even procedure, because the same patient, right? Same patient, going to the same doctor. So same patient, same doctor, let's say this and this, is still like with the same procedure, on the same day can have different procedures, right? So you may go, for example, let's say patient name is Baker, right? So patient code is unique, right? So now patient code, which belongs to Baker, and at this date, this specific date, goes to this doctor, and it may still have doing different procedures on that. So this may not even be the primary key. I don't know if I'm clear. So the primary key in this table could be a combination of doctor name, date, and so it should actually be like this. So this is your primary key. So your primary key is composed of different columns, because now patient code, doctor name, date, procedure, now this can be unique, right? And so is this a good primary key? Like if you're given this table and you want to put like a primary key for it, finding the primary key, is this a good one? No, obviously not, because what were like the characteristics, like the best characteristics for primary key? So we mentioned that, because if you just want to find out an attribute that can uniquely identify, that is unique, let's say, or can uniquely identify each rows, that's also a candidate key, right? But we may have several candidate keys in a table, but we end up with one primary key. For instance, you may have a student ID or a student number. You may have a student name, let's say first name, last name, and let's say this is a student first name. And then, for instance, several other columns, let's say also email. Now, let's say this is the email for students, like the university email, right? And then your assumption is that each student should only have one unique email. Each student should have one unique email in your database. So can I choose email as primary key? It's not the best choice, right? So there are many reasons for that. One is, as Ayman said, numbers. Jeffrey also said not to line, primary key not to line, because uh, so if I want to ask what are the candidate keys, right? So the candidate keys could be, for instance, a student ID, even like first name, last name. If your assumption is that, for example, let's say last name is not repeated in your database, let's say last name is not repeated, and email is also unique, right? So if these are all unique, so these are all candidate keys. But which one you choose as a primary key? You choose a student ID or a student number, right? Why? First, because it's numerical, and we prefer numerical short like values for primary key because it's faster for querying later. But also because this can guarantee that it remains unique, right? But for example, SID is also unique, right? But yeah, my assumption was that, let's say last name is unique and email is also unique. If let's say you have other columns that are unique, but they are not, for example, uh, there is no guarantee, for example, that they can remain unique. For instance, maybe in your current database, last name is unique. Maybe you have like only a unique last name right now, but can you guarantee that there is no like a student in the future, like adding to be added to your database with with a different last name from all students? No, you cannot guarantee that. There may be a student later added to your database with the same name. Or email, for example, emails can be updated or changed. Exactly, so email can also be changed, and also it contains a special characters. It's so long, so it is also not a good option for primary key. So same thing in this table. So a doctor name obviously is not primary key. Patient code is not primary key. So together we have like this composite primary key composed of 3 or 4 different columns. And when you have such situation, my recommendation is to add a surrogate key. And surrogate key is just a system generated primary key, right? It's just a automatic number is added by your DBMS. And so let me also remove this. And then, so that's why you see visit ID here. So let's say this is the visit report table, right? So this table is just showing the like each visit, let's say each row. So let's add a visit ID as the primary key. So you add like this unique identifier here. And then like in practice, like if I talk about surrogate keys are just like numbers, like 10000 10001, something like that, right? Not, it may not look like this, but this is just an example. So let's say you have now this single primary key here. And so as you see from the previous table to this table, so let's first finding the dependencies here. There are several dependencies, right? So for instance, if you consider like these 3 columns as your primary key, if you think like this combination is unique, and then what are your dependencies in this table? So let's say these like 3 columns are your primary key. What are the dependencies? Patient name depends on patient code. Exactly. So this is one dependency. So patient code can uniquely identify patient name. In your exam, please be careful with this direction, right? So you cannot write, if you write patient name, patient code, this is not correct, because this means patient name can uniquely identify patient code, which is not correct, right? And if I tell you a patient name, so 2 patients may have the same name, right? So you may have 2 patients with name Mona, right? One Mona is me, one Mona is another person. We have different IDs. Maybe my ID is 123, my patient code is 123. The other Mona's code is, for example, 456, right? So if I tell you the patient code, like for example 123, you can uniquely identify patient name, right? Because 123 means Mona. But if I tell you Mona, you cannot, it can be, for example, Mona 123, right? Or it can be Mona 5456. So this is not correct. This is how you present this. What other dependency you see here? A specialty depends on doctor name. A specialty depends on doctor name. Exactly. This is another partial dependency. So doctor name, right, can uniquely identify a specialty. Procedure and charge. Yes, thank you. So we also have procedure can uniquely identify the charge, because each procedure has a specific cost, right? For example, X-ray is $75 versus, for example, just an examination maybe $35. Chemotherapy is, for example, $50, and so on, right? So different procedures have different charges, and procedure, let's say procedure can uniquely identify charge. So in your exam, please write the complete names. Here, I just wrote like these weird names because otherwise it will be very slow. What if 2 procedures had same charge? Then there is no transitive dependency, because then procedure cannot uniquely identify the charge. Like for example, if you have, like if each procedure, let's say examination, has only one cost, then there is a dependency, right? Because then if I tell you, for example, examination, you can tell me it's $35. If I say X-ray, you can tell me it's $75, right? But if, let's say, it may happen that it's like, for example, this table. So let's say you have a student ID, course ID, a student, for example, course title, and then you have instructor ID and instructor name and maybe office, right? So now instructor ID here is the foreign key, and these two, let's say, is your primary key. We cannot guarantee the costs stay different in the future. Are you responding to Michael, or is it a separate question? Anyways, like back to Michael's question. So he mentioned, what if, for example, what if two procedures had the same charge? For example, if let's say X-ray also is 35, right? This is like, for example, let's say instructor ID 1. So let's say this is a student ID 1, 2, 3, some course with title. And then, as you know, like let's say each instructor ID in this table can be repeated, right? Because it's a foreign key, and foreign key should not be unique. So let's say you have instructor ID 1, 1, 2, and 4, like this. And then instructor name could be Mona, Alex, and some other names. And then this is, for example, Stevie 1 for D, 1 for D, and then different office like lesson and so on. So like in this example, if we had like, for example, two instructors, let's say Mona and Alex, if Mona and Alex have the same office, right? Then having, for example, instructor ID, we cannot uniquely identify instructor office, right? So in that case, there is no, so yeah, my answer was correct. So if in that case, there will be no transitive dependency. But the dependency means, for example, this, like regardless of the type of dependency, whether it's full key, whether it's partial or transitive, when you're talking about dependency between two columns, what does it mean? For example, if you say B, column B is dependent on A, or there is dependency between A and B, it means A can uniquely identify B, right? So if your column A couldn't uniquely identify B, then this is not a dependency. Now, depending on whether that dependency happening between, for example, columns with primary key or part of primary key, like all part of primary key, that will be full key. If it is dependency between a column with like part of primary key, that's partial. But then if there is a dependency like procedure and charge between like two non-key columns, then it is transitive dependency. Now, so here, as I said, so let's say if you had like procedure and charge, so you identified the dependencies here, right? So you identified these dependencies, like for example, doctor name and specialty. This was one partial dependency. Patient code, patient name, another partial dependency. We also identified one transitive dependency here, right? So in order to normalize this table, you have to, for example, let's say this table is not in 2NF and not even in 1NF. So the first step is to put everything into like two different things into two different cells, right? So you have to get rid of the repeating groups like this. So for example, this is one repeating groups, right? This is another. So this is avoiding, like for example, like this is another problem, right? Because now, for example, with the same doctor and patient, you have different charges, different procedures. And so you want to get rid of that. You want to have atomic values. So in that case, first you have to make this table into 1NF. Now imagine you did it into 1NF. Now, if the table is also in 1NF, so let's say you have then repeating like this with X-ray 75 in a different cell, like let's say this is Campbell, this, and this is in a separate row. So the table is not in 2NF because of the partial dependency, right? There is a partial dependency here, there is a partial dependency here, and there is a transitive dependency, which also means that the table is not in 3NF. But when table has already partial dependency, you don't even need to check like for transitive dependency to identify the normal form of the table, right? Because if the table is not in 2NF, so having partial dependency means it is not in 2NF. If it is not in 2NF, even if there is no transitive dependency, table cannot be in 3NF. So even if your table was this, right? Let's say there is no procedure, no charge, you only have this. So this table in the blue box Is it in 2NF? No. Is it in 3NF? No, because the table is not in 2NF. Table has partial dependency, so it is not 2NF. Since it is not 2NF, cannot be 3NF as well. But if I ask you what are the dependencies in this table, okay, then obviously you have to identify full key dependencies, partial dependencies, and also transitive dependencies. Now, based on this, so based on like these dependencies that we found, we are normalizing this table now. So normalization means like getting rid of this one messy, big, huge table, right? And breaking it into separate tables. How this breakdown happens? Using, for example, the dependencies, but with identifying your partial dependencies, transitive dependencies, and getting rid of those dependencies. So for instance, in this case, we put, for example, this transitive dependency in another table, right? So you have procedure and charge. We also added visit ID, right? Because we know that the procedure cannot be unique, right? So we can have, for example, examination. This is repeated because the same patient had, for example, same procedures at different days. So this couldn't be unique. And then let's say we have this table on the left. So what is the normal form? What is the normal form of the table on the left? 2NF, Michael says 1NF, Harriet says 2NF. So let's say primary key is visit ID. Partial dependency between what? Yeah, yeah, you're correct, Jeffrey. It's not. Yeah, the confusion might be because we had a composite primary key before, but we added visit ID. Now that we have visit ID, right? Now that we have visit ID as the primary key, so if this is your primary key, then we have a single primary key. In a table with single primary key, can we have partial dependency? No, we cannot. Because partial dependency means you have a column that depends only on part of your primary key. So primary key has only one part, it's visit ID. So there is no possibility of having partial dependency. So table is already in 2NF. Now, is this table in 3NF? No. So this table, what normal form, right? This is 2NF. Actually, I already wrote this. Now I realize that this is second normal form. I wrote this here, right? So this table is already in 2NF, right? But is it in 3NF? No, because there are transitive dependencies. Now, the dependency between doctor name specialty and patient code patient name that in previous slide, so in previous slide here, right? The dependency between doctor name specialty or patient code patient name, in this table, these dependencies, right? These dependencies are partial, and the reason is because doctor name was part of primary key here, or patient code was part of primary key here. So these dependencies were partial dependencies which violates 2NF, and that's why this table is not in 2NF. However, this table now, the table on the left, just by adding a primary key like visit ID, right? Just by adding, let's say, surrogate key here, then you get rid of like that problem. Now your table is at least in 2NF because now this same dependency, right, is not partial dependency. Dependency between doctor name and specialty is transitive dependency, right? The dependency between patient code and patient name right now is transitive dependency because these are dependencies between non-key column. And so is this clear? Okay, great. And the table on the right, this is this in first normal form? Yes, it is in first normal form because values are atomic. You do not have multiple values in one cell. And so is this table in 2NF, the table on the right? No, there is a partial dependency, is exactly. So there is a partial dependency between charge and procedure. And this is because your primary key is composite here. So you have visit ID and procedure as your primary key. And the dependency between charge and procedure here is partial dependency. Is there any transitive dependency? No, there's no transit. So the dependencies in this table, you only have charge depending on part of your primary key, which is only one partial dependency here, which violates 2NF. So the table is only in first normal form. Now, again, I lost my, okay, I found it. So let's get rid of this. Now, so this table was, we said this table is in second normal form and this is in first normal form. So if in the exam I ask you to normalize until, for example, 3NF, it means that our work is not finished yet. So we still have to continue. So if you want to further normalize this table, let's say the table on the left, right, this one, you have to get rid of like these dependencies, sorry. So the dependency between doctor name specialty and the dependency between patient code, patient name. How do you get rid of these dependencies? You put them in a separate table, right? So you have to, for example, putting doctor name and doctor information like doctor name specialty in a separate table, right? This is one. So when you want to normalize it, you create another table with like doctor name and the specialty, right? Putting this in one table, and then put also this one in a separate table with patient information, patient code, patient name, right? So this is how you normalize it. And then what is left is visit ID, doctor name, date, and then you also have to add the foreign keys to each table because there are some relationships between these, right? So that is how we end up with these tables here. So you will see we break that big table into 3 separate tables. So you break it from the dependencies. So for example, there was dependency between doctor name and specialty. Okay, that's fine. Put it in a separate table. There is a dependency between patient code and patient name. Okay, put it in another table. Remove it from like this big table. So you remove them from here. Put them in separate tables. Now, what is left in this table is visit ID, right? Date, and that's it. But visit ID and date alone are not enough, right? There are relationship between these tables, and that's why you have to add the foreign keys, which are in this case doctor name and patient code, right? Or maybe doctor ID in like maybe that makes sense if you're in your database you have, for example, 2 doctors with the same name, then adding a doctor ID here would make sense. Now, is this clear? Is this clear? Okay, great. So Krip asks, we don't need to assume if a doctor has more than one specialty. In this example, the assumption was that each doctor has a unique specialty. So for your exam, if I, for example, if you, for example, for your ER question, for your ER modeling question, if something can have different assumptions, like the case here, some students may assume that, for example, doctor may have different specialties. Some students may assume, for example, doctors have unique specialty. If there is such cases, I explicitly mention in the question. So, for example, I say, we assume that each doctor has a unique specialty. Okay, this way you can better identify the dependencies. So. Do you have any questions about how to identify the dependencies or how to break the table when you want to normalize it? Is this clear? Okay, so as you see, all these 3 tables are in 3NF right now, right? This is 3NF because the table on the left, we have a single primary key. There is no chance of partial dependency, so table is already in 2NF. We also have atomic values, which means it was already in 1NF. It is also a 3NF because there is no transitive dependency right now, right? And then looking at the doctor table, you only have doctor name specialty. Assuming doctor name is, for example, unique and this is your primary key, then the dependency between specialty and doctor name here is what type of dependency? Dependency between doctor name and specialty in the doctor table. What type of dependency? Full key dependency, exactly. So it's a full key dependency. Same thing for the patient. Patient code, patient name. This is a full key dependency. And how to further normalize the table? So here, sorry, this is back to this table, right? So let's say you have visit ID, procedure, and charge. This table was in first normal form, right? So we have to get rid of the partial dependency. to normalize this table. But if you look at the two slides later, so here we have just 3 columns: visit ID, procedure, and charge, right? Visit ID, procedure, and charge. But I also added procedure code, and this was right because we cannot choose procedure name as primary key because it may not be unique, right? If procedure name is not unique and charge depends on it, so a solution can be adding procedure code. And then, so now in this table, we have visit ID, procedure code, procedure name, and charge, right? So this set up for what normal form? So what is the normal form of this table? Okay, so first, when I ask you what is the normal form of this table, the first thing you have to do is to identify the primary key here. What is the primary key in this table? So is visit ID unique here? Composite, right? Here we should have a composite primary key, right? So this table, yeah, composite, no, right? No, that's correct. So this table should have a composite primary key because as you see, visit ID is repeated, so visit ID is not unique. And the reason is because this table is not a visit table, right? So this is not a visit table, so visit ID is not unique here. And procedure code alone cannot be also primary key because you can see that we can have, for example, same procedure, right, in different visits. So for example, let's say a customer visit, for example, today, right, have a visit today with, let's say, procedure x-ray, right, and then in another visit another patient or the same patient may have the same procedure, right? So procedure code can also be repeated. So let me visit ID and procedure code, exactly. So visit ID and procedure code can uniquely identify each role right now, because let's say in the first visit, right, you do, for example, this procedure 1, right? So if our assumption is that in each visit you cannot have more than 1 procedure, right, then this can be your composite primary key, which is the case here. Now let's say this is your composite primary key, visit ID and procedure code, right? So if this is your primary key, what dependencies do we have? So let's assume that visit ID and procedure code, right, these 2 columns, let's assume like these 2 are your composite primary key, right? This is composite primary key. Now the dependency between procedure code and procedure name, right? So this is a partial dependency. So since we have partial dependency, right, with procedure code and procedure name, the table cannot be in 2NF, right? So yes, so 1NF, right? Yes, is 1NF. And so I'm reading your comments. So right, procedure code and name, exactly. Hallelujah. Transitive dependency also procedure name and charge. Isn't there transitive with procedure name and charge as well? So now, okay, so if the goal is just to finding, if I ask you, what, for example, what is the normal form of the table, right? So even if you find only 1 partial dependency, you know that the table is not in 2NF, right? If the table is not in 2NF, cannot be in 3NF. So you don't even need to bother searching for transitive dependencies, right? Because for a table to be in 3NF, right, it means 2NF plus no transitive dependency, right? But if table is already not in 2NF, so it is not also in 3NF. So if my question is, what is the normal form of this table? So primary key, visit ID, procedure code. Okay. Now, functional, okay, dependencies, procedure code, procedure name, right? So this was 1 partial dependency. So if I ask you what is the normal form of this table, you only need to find even 1 partial dependency. You know that it is not even in 2NF, right? So the normal form is only 1NF. And that's because you do not have multiple values in each cell. Your values are atomic. So table is in 1NF, but not in 2NF because of partial dependency. Now, the dependency between procedure name and charge, you said, because we already have procedure code, right? So I would say that dependency will be procedure code charge, not procedure name and charge. So I would say this is still partial dependency between charge and procedure code. Does that make sense? And then the dependency between procedure name, if you mention the dependency between procedure name and charge, right? This is transitive. So this is transitive. But this one, part with procedure code and charge, this is partial dependency. Now, anyways, we have partial dependencies, we have transitive dependencies, so the table is not in 2NF, it is not in 3NF, right? The table is only in 1NF, and that's because we have atomic values, right? So in which NF is 1NF. Functional dependencies, we already identified that. What is the foreign key here? What is the foreign key here? Visit ID. Visit ID can be, because this is not a visit table, right? So if you check the previous table, look at this table, this initial table which we normalized. Now in the table on the top left, this one, this is your visit table, right? Visit ID is your primary key, right? Because this table can uniquely identify each visits, right? So it includes visits information. Now, like for example, enrollment table, if you consider a surrogate key like enrollment ID, something like that, or even a normal table like a student table with a student ID. Now, visit ID can uniquely identify its rows. So visit ID here is primary key. Now, because it's primary key in the visit table, now in this table, this is foreign key because your primary key was visit ID procedure code, right? So your primary key is composite primary key. And then, so your primary key is composite primary key. In that case, then visit ID, right? Alone, this is foreign key. This is foreign key. If there is any other columns also like appearing as the primary key in another table, like for example, in the procedure table, we have procedure, for example, code, procedure name, and charge, right? And then if, for example, procedure code here is your primary key, then this is after normalization. Like here, we only have visit doctor patient, right? And so we do not have procedure in any table right now. So this is not a foreign key here. So foreign key here is visit ID. No, because procedure code, right? This was actually the procedure table, right? But because it wasn't like here, if you see like this table, let me go back. So we initially started with like these two when the first normalization step, right? After this was breaking it into these two tables. So we first normalized the table on the left, which resulted in these three tables: visit, doctor, patient, right? So this is based on this table on the left. And then we set the table on the right, right? This table is also in first normal form, and we also need to further normalize this table. Now, normalization of this is in the next two slides. Here, procedure code name charge, we also added visit ID, right? So now that we added visit ID, right, and we have like this composite primary key, visit ID becomes the foreign key, right? And so this table, we identified the partial dependencies, and the normal form of this table was a C1NF, and then so you can think of it like, for example, in this table, the problem is that you cannot choose procedure name as primary key because it may not be unique, right? And charge depends on it. So our solution was to add procedure code. Now your table now has like these four columns, and now this set up for 3NF by separating procedure details, right? And there is a many-to-many relationship between visit and procedure if you check, right? There is a many-to-many relationship because each visit can include multiple procedures. For example, visit 1, in your first visit, you can do both examination and X-ray. So each visit can have multiple procedures, right? And each procedure in your treatment can be used for multiple visits. For example, X-ray can be used, for example, in visit 1. X-ray can be used in visit 4, and so on. Does it make sense? So this is a many-to-many relationship between visit and procedure. So now we see like this, so you break it down, you want to further normalize now this table. So I assumed, like, I named it treatment because I think it makes sense. So I created a relation or table for treatment because there was a many-to-many relationship between visit and procedure, right? And so treatment here is composite entity in your ER model. And as a composite entity, treatment takes the primary keys from both tables, right? That is visit ID and procedure code. So what is the primary key in the treatment table? Composite primary key, right? Visit ID and procedure code together can form a primary key. So this is the normalization of this table, right? So in this table, as I mentioned, we had a composite primary key, visit ID and procedure code, right? So this is a composite primary key. And then there was obviously partial dependency as well. So we want to get rid of that. So the first step is to separate these into two different tables. So in one table, I have, like, for example, so in one table we have procedure code, procedure name and charge, which include procedure information, right? And in the other table, treatment, we have visit ID and procedure code. So as a composite entity, treatment, like this is your treatment table. Treatment takes the primary key from both tables, right? This is a relationship between visit and procedure. So let me annotation again. So this may help. So this is visit, right? This is visit. This is procedure. Now, what is the relationship between visit and procedure? What is the type of relationship? Many to many, exactly. So there is a many to many relationship. Each visit can have one or more procedures, and each procedure can be used in, for example, 0 or more visits. So this is a many to many, and therefore we need an associative entity. And this is actually your treatment table, right? So let's, So this is your treatment table. Now, this treatment has a composite primary key, visit ID and procedure code. As I mentioned before, each composite entity has at least two attributes, right, which are the foreign keys, because if visit ID here is the primary key, right, and if procedure code is the primary key here, and because this is a one-to-many relationship, right, so each procedure can be in one treatment, and so let's say this is a one-to-many relationship. So these are also the relationship, right? Now, visit ID and procedure code, right? Each of them alone is foreign key because they are primary key in another table. And then in this case, also because I converted this into just wanted to make this correct in case, especially because you may watch the recording, so I didn't want to put it like in a, so this will be the menu, right? Because I added this as a composite entity. So this is the menu one, and then this is one. And so I may assume that this should be one, and its procedure may be used in any treatment, or maybe at least in one treatment. So it depends on how you assume it. Oh, thank God, I thought I went nuts with the cardinalities. Okay, good. So are you okay with the cardinalities here? No, you didn't go nuts with cardinalities. Sorry. It's because at first I had this relationship between visit and procedure, right? When I have visit and procedure here, right? So this was the many-to-many relationship, right? So this is the many side. That's why. And then when you convert it to associative entity, then this will change, right? So you didn't, you were actually correct. Now, so I draw this only to show you why we have treatment here, right? So that is what treatment shows. And so from the ER perspective, treatment is a composite entity created because visit and procedure have many-to-many relationship. But from the normalization perspective, right? From the normalization perspective, it is like that normalization resulted in two clean tables, right? One of them was treatment, which include visit ID and procedure code, and the other is procedure, including procedure code, procedure name, and charge. And now all these two tables are also in third normal form. Now, if I go back to the first original, so we are done with the normalization of this example, so this is done. I just want you to the first table. So this first initial table, right, step one, we broke it down into these two tables. Now each of these two needed further normalization. For example, the table on the left, we normalized it into these three tables. How? We found the dependencies, like this one and this one. We got rid of them, put them into a separate tables. What is left here is this one, which is the visit table. So these three tables are the result of normalizing the table on the left. Now, what about table on the right? The table on the right, we added procedure code because we said procedure name may not be unique. Even if you don't do it now, later when you want to normalize it, right, then you should add it here. And so we also further normalized that, and then we ended up with like these two tables. And I also explained it from the ER perspective so that it better makes sense why we only have like these two columns here. And so these are just some more, for example, information here for you. Like, for example, I also draw the ER model here. Like, don't need SQL for now. We spent several sessions on SQL. And yeah, that's it. Unfortunately, we couldn't run them. I prepared some Kahoots. So these are also about like remarks and normalization. So I think you already know that when we need to do normalization. Kahoot time. Yeah, unfortunately, the class time is finished. I don't know if you want, I'm fine with staying here if you want to play Kahoot, but I don't know if that's what everyone wants. So Jeffrey has another class. So let's okay, right, yeah, that makes sense. So let's do it at the beginning of the next class. So in this case, we will make sure we don't miss it. So we do Kahoot Wednesday. So at the beginning of the class, I promise, because we're done with the normalization. So in this, like, just why, like, we don't need to normalize tables always. Sometimes we also denormalize, especially when I talk about data warehouses later. You will realize how we also denormalize our tables sometimes. If, for example, your priority is, for example, for read purposes, like, for example, for analytics mainly. And if, for example, your joins are very slow, when you want to join tables, it is very slow because each table contains multiple columns with dependencies. And so in those cases, we need, for example, also to denormalize tables. Like, for example, you are building data warehouse, your joins are slow. So these are the cases you need to denormalize your tables. And so denormalization only helps you with like the join complexity and your query performance, but we also sometimes normalize. Normalization is just to make sure the data is, for example, the redundancy in our tables are minimized, right? But it depends on the case. So as I mentioned, sometimes we need to denormalize tables. For example, if you're optimizing for read performance, right? For example, in your analytics or reporting systems, or if you realize your joins are too costly or slow because you have to, what happens when you normalize? You break one table into several tables, right? So later, this may cause like several joins, right? Because instead of accessing everything from one table, then you have to join maybe 3-4 tables. And then if joins are too costly or slow, or if, for example, you are building data warehouse that I'm going to explain later in this course, those cases you need to denormalize tables. And I also explained denormalization. I'm going to explain more about normalizing or denormalizing next session because we have time. But if you are in a hurry and you want to like see, I provided also this table to like as an example to better understand like these concepts. And this is just an example. So I started with this example and put this table here. I'm going to explain it explain it next session. And that's it. So we almost done. Next session I'm going to start with Kahoot, and then we finish on this, and hopefully I'm going to start the SQL and helping you with the installation. Do you have any questions? Exam format has been released. I think I provided a general guideline for the midterm. So your midterm should include multiple choice questions. I don't know if you have checked my announcement, but should include it's a combination of multiple choice true false and some problem solving. 50 to 60% of the weight is on problem solving, which include, for example, a question about ER modeling. So I give you a case, I ask you to draw the ER model. I may also give you, for example, tables to normalize or asking for functional dependencies. So there will be some problem solving, and then you will have also 10 to 20 multiple choice questions covering all the topics that we covered in class. I'm going to provide more detailed information closer to your exam. Do you have more questions about the midterm or the course? Okay. Thank you. Thank you, everyone. Okay, so if there is no more questions, I'm going to first stop sharing my screen and then stop the recording. And recording stopped. Have a great day.